Hello, everyone. I am Zach Blumenfeld, a product specialist here at Neo4j. And today I get the privilege of talking to you about Neo4j Aura Agent, which is an end-to-end platform inside of AuraDB that lets you build agents grounded on top of knowledge graphs, and was just released for general availability not too long ago. So the way I've structured this, pretty simple. We're going to try to pack a lot into this approximately 30-minute talk. I'm going to talk a little bit about the challenges with agentic AI and building AI applications, and then how Neo4j Aura Agent addresses some of those challenges. I'm actually going to walk you through the product and talk you through sort of how everything works. And then we'll go over availability and pricing and some additional resources if you want to follow along technically or just read more about the product and how you can apply it for your own projects. So to get us started, when we think about the challenges with agentic AI, and there's a lot, right? But what I want to focus really on here is the data integration and AI-ready gaps. So when you have an agent that's very heavily tied in or dependent upon your enterprise data, say you're working in healthcare and need access to medical records, or life sciences, access to research papers, maybe in something like legal or finance where you need access to legal documents or contracts or other transactions. If that data isn't tightly integrated with your agent and your agentic infrastructure, you can run into a lot of different problems. At Neo4j, if you've listened to some of our other talks, we talk about issues with accuracy when you do not have graph retrieval augmented generation. And that definitely shows up when you have poor data integration and your data isn't AI ready. But in addition to that, what you also end up having a lot of the times are long development cycles, because basically your engineers have to work harder to be able to make your data and your agent get along, essentially, with inside of the right deployment infrastructure and testing infrastructure and all that sort of stuff. And you can end up with very complex and sprawling AI architecture, right? So if you have multiple different data stores that are maybe somewhat fragmented and you're trying to get that to work with your AI application, there might be a lot of different integration points and sort of separate ad hoc different apps that you need to spin up to make everything work together. And when we really break this problem down, we can think of it in terms of runtime challenges and in terms of construction time challenges. And I'll talk a little bit about what I mean from that, basically what's actually causing this problem. And when we think about runtime challenges with agentic AI, there's two things. There's grounding failures, basically where the agent struggles to understand the context of your data. Really, I'm going to use the word ontology and sort of the schema of your data. And it says tool calling. That's a typo. It should say tool calling. But basically when to call the right tools and sort of how to understand the domain so that it can figure out how to put the different pieces of data together when creating a response for a user. If you're trying to access, again, if it's life sciences, it might be research. For finance, it might be transactions. For legal, it might be different types of contracts or legal documents. And then you also have runtime infrastructure. And that really refers to, can you deploy your application securely? And do you have the ability to link that application up in that secure sort of production-ready environment to all the different data stores that you need to retrieve data? And then on the construction side, which often gets overlooked, you have a couple unique challenges there. And the first one, and one that's personally pretty sort of ingrained or something that I think about on a daily basis, is design gaps in how we actually construct agents. So if you're familiar with ontologies, the term, right, it's in concept, an ontology is really a schema and logical rules about your data and the use cases and how you apply basically logic to your data, right? And in theory, if you know your ontology, basically if you know the business rules around your domain and the schema of your data, that should be enough to at least draft an initial enterprise AI agent, in theory. But oftentimes we don't have the actual tooling to make that happen. So, and without that, basically what we're left with are subject matter experts trying to put that initial agent together. And that can form a bottleneck, and it can take a long time, weeks, to be able to just get that initial agent that works well inside of your infrastructure. And then the second part of that is the actual testing and development that comes after that. So do you have the infrastructure that enables rapid iteration and refinement and testing and debugging and evaluation of agents and all of these things to really get it to a point where you can productize it and actually use it in a production scenario? And Neo4j Aura Agent, you can think of it as solving a host of these challenges. So if you already have a knowledge graph inside of AuraDB, basically this is a platform that sits on top of that and allows you to build knowledge graph agents or agents grounded in those knowledge graphs in a matter of minutes. And there's specific pieces of this, sort of how this technology works, or the architecture, if you will, that when taken together, create this solution. So if I was to describe sort of the value proposition and what Neo4j Agent does, it's split up into 4 pieces. The first piece is ontology-driven AI, or you can think of it as like graph-driven AI. And this is the ability, and it's a new feature that we came out with this year, to auto-generate ready-to-deploy agents in a matter of minutes, sometimes under a minute, that's customized to your graph schema and use case. And I'll show you how that works in a walkthrough. But in essence, it's this ability to at least draft an initial agent based on the shape of your data and a description of your use case. After that is the accurate and agentic GraphRAG. So basically being able to improve the accuracy of your results. And we've talked about GraphRAG a lot if you've listened to some of our other content. But there's a combination of tools that come out of the box here, from vector search to query templates, and also text to query or text to cipher. In our case, since we're using the cipher graph query language. And then advanced reasoning and explainability. So the agent that we're using in this case, it has chain of thought reasoning, so it can sort of break a problem down. And then because it has access to a graph, you get sort of this multi-hop graph retrieval type of reasoning, which is really great. And it's exposed transparently inside of the agent response. And we'll see how that works. And that contributes to more explainability and trust, especially as you start building more complicated systems. And you're dealing with really critical data where users are going to ask, like, how exactly did you come to a certain answer? And the last very important part of this is single-click deployment. In this case, again, this year, we have a hosted now MCP server, in addition to our REST API, which we've had for a while. And this is in the cloud. It's inside of Aura. And that greatly simplifies your AI stack and some of the runtime challenges that we were talking about earlier, because it essentially allows you to take an agent and just with a click of a button, basically get it behind a secure, authenticated endpoint that you don't really have to manage independently. So I'm going to walk through each of these 4 areas. And as I do, I'm going to walk through the product as well and show you how it works inside of the Neo4j Aura Agent. So starting with this graph-driven or ontology-driven piece, in effect, what we do is we take the graph schema and the use case description, and for our intents and purposes, I'm referring to that as an ontology, and it uses that to automate the tool and the prompt and sort of the description of the agent, all the metadata for the agent, that construction, to get you this ready to deploy agent, which is really fantastic in the sense that something that would normally take you a while, you can now get in a matter of minutes, and you're really driving the agent by the ontology or the structure of your knowledge graph that you've worked so hard to create. So I'm going to go and show you what this looks like with an example here. Basically, I've got a few things running. This is my personal account, so forgive me, but I'm going to focus on this employee graph database. And I'm just going to show you what the schema looks like really quick for this guy. I'll make the code available in the resources as well. So when I go over the last part of the resources section, you can rebuild this whole graph yourself. But what I'm going to do here is I'm just going to call for the schema visualization so you can see the type of graph that we're going to be looking at here is an employee graph. So what I mean by that is this is sort of like an HR use case where basically, let me try to organize this window so it's a little bit easier to see. Here, take this down. This graph is going to contain people nodes representing basically a bunch of people from the resumes that we ingested into this graph. They're going to know different skills. So things in this case like Python or C++ or C# or AWS, mostly focused on technical skills in this use case, and different things that they accomplish. So these are like different projects, things that they've published, projects that they've managed, research papers that they've written. And those exist inside of different domains, and they're of different work types, which creates this connected graph. And so the agent that we're going to want to build here is basically going to be a reflection of, wanting to create an agent to help us with skills analysis and backfilling and telling us basically about our skills distribution and how to apply people to different projects at the company. In this case, a fictitious company because all the data is AI generated. But if I was just to grab a sample of this data, I can look at just maybe grabbing a sample with Cypher here and make that a little bit bigger so you can see. But you can see here how we'll have these different people. So if I click on a person, this person basically knows this machine learning skill, and then this other person knows that machine learning skill, and they've worked on these different pick nodes, which are different projects here. If I bring this up, it'll make it a little easier to see, so you can see what a person looks like. They have their resume text associated with them, some other metadata about their department, and then these common skills that they all have worked on, different projects here, and then you can see how there's shared domains or work types that actually connect between the different people. So it's a pretty rich graph, again, extracted from resumes and some other CSVs that were generated. And with this graph, say we want to go ahead and build an agent to help us with some of that skills analysis stuff. Well, we can go into this Neo4j Aura Agents tab. You can see I've actually built one here, but I'm going to create a new one. And you can create them from scratch. I'm actually going to select to create with AI. And this is this ontology-driven piece that we were talking about. In this case, because I already am connected to the employee graph, it's pre-connected. And then I give it a prompt, basically to describe the type of agent that I want to build. And I am going to go ahead, and I've already written one for this. Basically, I'm going to tell it to, hey, create an employee knowledge assistant responsible for skills analysis, talent search, and team formation at Cyberdyne Systems, which is my fictitious name for this company. And then I give it some examples of types of questions that it might want to expect. And I have a little more information in here about sort of the type of, queries and stuff that I want it to write, just from having done this a couple times before. But when I go ahead and press, and also I have the option to add embeddings. So I do have embeddings on the resumes here. I can select between Azure OpenAI as well as Gemini, Vertex AI embedding models. So you just want that to match whatever you used in the data set, which is what I've done here. And then I'm going to go ahead and click create. And as that's running, it's going to go ahead and pull the graph schema along with that use case description that I gave, which I'm calling an ontology here. And as it does that, it's going to eventually create an agent out of the box for me. So we're going to go ahead and give that a minute to run. But it's very convenient in the sense that it's going to build out quite a handful of tools for me that ordinarily, I would have to write by hand each individual one. All righty. So it's already come up for me. You can see here it's given me a description for the agent as well as a name. And then it's actually given me a pretty detailed prompt, which is sort of like your system prompt instructions. And then it's given me a bunch of tools down here, which are retrieval tools that we'll get into in a second. But now, all of a sudden, out of the box, I could go ahead and start asking it questions. So, for example, I could ask a question like, how many Python developers do I have? And just see if this works. It'll take some time to think about it, and then hopefully use the right tools to grab the data. I've verified this before. 28 Python developers, if you can see it there, is the right answer. And it will give me its reasoning and what it's done there. So you can see already out of the box, I have a working agent. I can even deploy this if I wanted to. I'm not going to yet. But very convenient, all sort of set up for me out of the box. So that's what I mean by ontology-driven or graph-driven AI is getting this agent very quickly. And go back into my slides, and I'll talk a little bit about the next part, which is accurate agentic GraphRAG. And we'll talk about the tools in this section. So basically, what you saw a little bit before, and I'll jump into it again, there's 3 different types of tools, powerful tools that are offered for doing retrieval from the knowledge graph. They've already been customized to my use case, and we'll see how that works in a second, because effectively what I just did before provided descriptions and sort of custom logic inside of a bunch of different versions of these tools. If I was to look at that inside of my agent here, maybe I'll make this a little bit bigger so it's easier to see. As we were saying, there's 3 types of tools. There's cipher templates, there's text to cipher, and then there's similarity search. And because I have more than 3 here, there's multiple instances of these tools. So for example, if I look at a cipher template, maybe find people with similar skills, for example. What happens is it'll give a custom description for the tool. These can be parameterized. And what this is doing is it takes a person name, and then it will find and rank other people with similar skills to that person using this cipher, which is the graph query language pattern, where it says, hey, find those people, and then see who knows certain skills, and then other people that know those skills. And then it's going to basically do this count distinct and ordering so that you have the people with the most shared skills at the top. So you can imagine this would be a very convenient query to run if you wanted to backfill someone for a specific position who has a similar skill set to someone else that's leaving. And there's multiple different versions of this tool, right? There's simpler versions where we might just want to count people who know a certain skill, right? That was actually used in the last query that we ran. So that's cipher templates that have all been customized. Additionally, there's text to cipher, as I was talking about before. What this basically does is it allows the agent to dynamically run and execute its own cipher. So being able to generate cipher queries when there's not a cipher template available. So sort of like custom on-the-fly graph logic and sort of pathfinding logic, if you will, to be able to aggregate things. So it serves as a really good fallback and is sort of a very good on-the-fly tool that the agent can use. And it's given some custom instructions here. Basically, these are good to use for counting things oftentimes where similarity search might not work, because similarity search has top K limitations, and counting them in a way that you might not have accounted for with the other cipher template tools that were created. And then the third type is just simple similarity search, which in this case is vector search. In this case, it's on different node properties inside of the graph, and this will retrieve people based on their text description. So if you wanted to do similarity search based on resumes, which are the text descriptions inside of each person node, this tool in this case would allow you to do that. But the similarity search tool type in and of itself can be applied to sort of any form of vector search that you have in your data, whether it be like legal documents or research papers or what have you. So I'm going to go ahead and save that. If I wanted to, right, I can go in here and I could create my own tools. I can also go in and edit these tools. I can edit the cipher here. I can edit the descriptions, all that sort of stuff. And I can actually test stuff inside of this UI, which is nice. So for example, like you saw before, I asked this question, how many Python developers do I have? It returned to me that there are 28 Python developers. I can go in and I can see that it used the person count tool here to be able to figure that out. If I had a more complicated question, it could do that too. So for example, I can ask a question such as, can you summarize my technical talent and skills distribution and the types of things people are currently working on? And in some of these cases, what actually happens is instead of just calling one tool, the agent might go ahead and call multiple tools and multiple tools of different types. That goes into some of the chain of thought reasoning or multi-hop reasoning that the agent can do. Behind the scenes, just so you know, the language model used at runtime is Gemini 2.5 Flash currently. So that just works out of the box. You don't have to provide your own API key or anything for that. So you can see here, it counted technical skills and the types of things people are working on. And I think because my screen's expanded, it's having a hard time scrolling down. But basically, the types of things people are working on here. And again, I can go ahead and expand this, and you can see it actually decided to use text to cipher for a lot of this because it was just a general aggregation question, and it sort of, I guess, the agent decided that it needed its own customized queries to go ahead and answer that question. And let me talk a little bit about actually what's inside of this reasoning tab. So I won't go back to the slides for this part to show you my pretty picture because I guess I'm already inside of the demo. But the third pillar out of the four that I was talking about earlier was advanced reasoning and explainability. And when you look inside of these boxes, this is what we call the reasoning tab. When we deploy to production, it's also exposed inside of the response format, and we'll see how that works. But again, the agent is using this sort of advanced chain of thought reasoning, and then it's able to string together these different tool calls. So I can go ahead and expand on the reasoning in this more complicated one, for example, and you can see, well, you probably can't see what it's saying because the text is really small. But it's basically saying, hey, I need to break this down. It thinks about what tools to call. It decides, okay, I might need to call this text to cipher aggregator thing because it's built specifically for aggregation. And then you can see, actually, if I was to open up the tool call itself, there's an input and an output. I can see the input, which is, hey, I want to summarize the distribution of technical skills and the types of projects people are working on. In this case, it had a couple errors in generating the cipher, and that happens sometimes. In fact, one of the great things about having an agent, now that we got this error, is agents can make mistakes, and that goes for generating query statements too. But it can go ahead and retry that. So it says, okay, well, I ran into that issue, and then it will try to do it again. And then you can see here the query, and then basically returning number of people. So you could see it does like this skill aggregation query, and then it will count the number of people with those different skills. And it will try to run some different queries here. So summarize projects people are working on. In this case, it does a query, and I know you can't read it. I'm sorry, it's quite small. But if you go ahead and use the project in the getting started example, you can see it for yourself. It only takes a couple minutes to get to this point. But you can see here, it'll look for these, what we call pattern matching. So it will take a person, look for the things that they're working on, and then the different sort of work type that falls into, and it will go ahead and aggregate that. And then down here, I think it will, again, do some different aggregations by work type. This is just aggregating on the project level. So in summary, right, you have sort of this reasoning tab that explains exactly how the data was retrieved. in addition to the reasoning that was used here. And that's very valuable, not only in that, I talk about advanced reasoning in quotes, right? A lot of agents can do that. But what's valuable here is taking that graph logic and actually sending it to the end user or an intermediate application. It just offers a lot more transparency and deterministic, or I guess transparent logic, which helps people trust your application. It helps developers explore how things are working, so that they can make things better prompts, better queries, better tools, and just improve trust and adoption overall inside of your AI application. So the fourth pillar that I want to talk about is secure deployment, single-click deployment. What you can do once you have your agent, so say I've gone through here and I'm not going to sit here and tweak my agent in front of you, but say what I have right now is what I want to actually deploy, and I want to start having end users use this application. Well, all I have to do is go to here, and it says access internal. Right now it's just available to basically people inside of the Aura project. But if I hit external and I say enable MCP server, what this will do, I'll go ahead and save. I guess I have to create the agent up here. We just changed the UI recently, so if you see me fumbling around, I've done it before. It's just been it. I did it before in the older version of the UI, so I apologize. But anyway, this is now external. And because I selected the option to make the MCP server available, but also this endpoint. So you can call this agent now in two different ways. You have the external endpoint, which is a REST protocol through our Aura API. That has a token authentication associated with it. I won't walk through that here, but just know it's a secure way to call the agent through REST. So basically you can call it from any app. The one that I'm going to focus on here is calling through the MCP server. And what that allows you to do, if you're familiar with MCP or Model Context Protocol, is it allows you to call this agent from another system that is compatible with MCP, which a lot of AI clients are. So if you want to call it from Copilot or from ChatGPT, in this case, we're going to call it through Claude. You can call it through Cursor. Pretty much any user-facing AI tool or AI agent generally has this MCP integration, or they're working on doing it. But anyway, for Claude, what I'm going to do is I'm going to say I want to add a custom connector. I'll just call this expert agent, and I'm going to give it the MCP URL that I just copied. I'm going to say add. And then it's going to take a while there for it to load up. And it might ask me to go ahead and connect. This is the OAuth protocol. So this allows us to basically secure the access, which is important if this is your own proprietary data, right? So I'm going to go ahead and just authorize this. And then once that's done, I can go in here and configure. Right now, this needs approval. I'm going to say always allow, just so that it doesn't break us up too much. And then now this is effectively sort of in production, or it's deployed. So I can go ahead and create a new chat. So let's see if there's an easy way for me to do that. How do I get to chats? Someone's probably screaming at me right now. I'm so used to doing it in the desktop. Well, new chat. Can you summarize my technical talent and skills distribution? So basically the same question that we asked before. I am asking it to include some simple graphics. So this is going to take a while because I asked it to include graphics. So we might have to come back to this if it decides to take a little bit of time to access the agent. But the idea here is, and it's going to grab some more information. So basically, it's accessing right now, and then it's going to produce a visual. let me go back and talk about some of the resources, and then we can come back here to see the result. Point being, right, that I was able to deploy this thing, and now I can go ahead and access it. It was very easy for me to do. It was completely no code. But I'll go ahead and come back to this just for time's sake, because I think we're already almost at time. So let me talk a little bit about the pricing and also where this thing is available, how can you actually use it, and then some resources for you to get started yourself. So Neo4j Aura Agent. This is actually free for the whole month of February. So there is still some time to use it while it's free, I believe, if you're watching this live. However, starting in March, users will start to accrue charges. So if you're doing just the internal testing stuff, you're not charged at all. It's completely free to use. Once you hit external, like we did before, so that I can access it externally, then it's charged at 35 cents per agent hour, which I think works out to around 250 per month. Again, internal agents aren't charged. This is available on multiple tiers inside of Aura. So if you're not familiar, Aura, which was that console that I was walking you through when I was showing you the agent and the graph, that's our cloud software as a service offering. It has the Neo4j database in there, Aura agents, and also lots of great dashboarding and visualization stuff and data import and all these great things. So for Aura Free, Aura Professional, and Aura Business Critical, this is available. So that's if you go and you just you go online and you go to Aura, you can access those tiers right now. So it's basically available for you to use for free, and then there's a small charge if you do decide to make it publicly available. And so some resources for you to get started. So the first thing is, if you just want to run through the example that I was just showing you, there's a link here to a web page that will give you the database and also everything you need to basically plug through and run through what I was just going through. There's also a developer guide that I've made where you can go to that guide and it will give you additional links like to the documentation, for example, some other examples like with legal contracts and know your customer. So just different use cases. We have a launch blog that goes over basically a lot of the same stuff that I did here. Also some customer stories and some other interesting things. And then the web page, which we keep up to date for general information on the product and all the latest content, different videos, other examples, Graph Academy course for free learning and all this other stuff. So that's our resources. And hopefully by now our results are done. Yay, they finished. So you can see here, sorry, I'll snap back over to the resources page after this, but I did want to come back here just to see that we completed, and we did. So we produced our little report, and you can see here how it's calling that our basically our expert agent, our Cyberdyne systems employee knowledge assistant multiple times. And you can even probably go in here and see that explainability piece, right? So I can make a request, and then you can see the response format. Maybe you can't see again. I'll make it a little bigger, where it would say I need to, do all of this stuff. And then it looks like in this case it wasn't able to do something, but that's why we have agents that can make multiple tool calls. Maybe it got it up here somewhere. Yeah, here we go. So it has the response format up here. I was able to pull some things back. But in either event, you can see it was able to pull all of that back, explain how it got the data, the retrieval logic, and then it created this nice visual sort of doing our breakdown of our technical talent distribution, skills, projects by domain, and all the great sort of on the fly UI and dashboarding stuff that we know Claude is great at doing. So anyway, I'll bring this back up just so you can see the different resources and go ahead and take your snapshots, and we should be sending something to everyone after this as well, I hope. If not, you can just go ahead and ask some questions, and we will get back to you with these resources. So that is all I had today. It was a pleasure being able to go over this with everyone. And yeah, go ahead, use it today, provide feedback. We're always excited to iterate and make our product better as needed. Thank you, everyone.